Once again, welcome to our online seminar. So, just an introduction about me. My name is Tinu Thomas. I work as technical manager for Fisher in UAE. I have around 11 years of experience in construction industry, out of which 8 years or so is in fixings. So today we are going to talk about mainly chemical anchors, so where I have a good experience. My user ID for your interaction today would be Tino Thomas. During this online seminar, if you have any hindrances, your technical support representative would be available under the user ID Fisher Mia. So please reach back to us if you face any trouble viewing the screen, be it sound clarity or some difficulty in joining. Please reach back to us. This is today's agenda. So the total duration of the online seminar would be 45 minutes. That's from 3:30 now till 4:15, followed by a 10-minute question and answer session, and further followed by a poll for 5 minutes. Here are some recommendations to make your experience trouble-free. Try to use Google Chrome as your browser. Do not use Internet Explorer. We don't recommend because it might affect your experience. Please try to avoid any parallel downloads so that your internet speed is uninterrupted. All your questions would be answered at the end, and all the answers would be mailed back to you, so that don't worry if in case we have a lot of questions and if for some reason I missed to answer your question, we would compile all the question and relevant answers and it would be mailed back to you. I hope you all would be having a screen similar to what you can see now. So first things first, please try to make it full screen for better experience, better picture quality, and better understanding, better reading of the words. You have a chat window where you can chat with us, interact with us. Even if you have any troubles, you can also mention that in chat window and we will quickly take action. I would ask some interaction, some questions also that would be in the chat window. Now the second thing is questions. In the question window, please make sure that if you feel you have any question regarding to the content, please post it in the questions tab and not in the chat window. I repeat, any questions you have which you need to ask me, please post it in the questions tab and not the chat window, because we'll be having a lot of normal casual interactions. I don't want your questions to get lost. And last thing is poll. Your feedback is very important for Fisher to improve our services. So please, before you leave the session, give us your honest feedback about how the session was, how we can improve our services, and what you like to be added in the coming sessions or so on. So please, we value your feedback and we are looking forward to receiving your valid feedback. Thank you. To begin with, let's start with a brief introduction about the brand Fisher. So Fisher is a German multinational company founded in 1948 by Mr. Arthur Fisher. I'm proud to say that we have more than 49 subsidiaries worldwide, distributing our products to more than 100 countries with a global workforce of more than 4,600 people. And here is the fun fact. Here is the most important fact about Fisher. We carry one of the highest international patents within the organization. It's around 1,500, and then we produce more than 15,000 articles. Fisher is a German company, as I mentioned, founded in Black Forest, and we have all these black dots indicate the countries where Fisher is present. Let's dive deep into the topic today, which is chemical anchors. So here I present 10 different important facts which is important for you to know about chemical anchors. So what is a bond strength? Can I ask you a question this afternoon? What is your understanding when you hear this term called bond strength? Or why do you feel it is important as an engineer to know about bond strength? Can I have some interaction? Can I have some reply? Okay, so bond strength simply denotes that it is the force which the chemical anchor can take per square millimeter square area. So a chemical anchor, when you compare two chemical anchors, you can say one is superior to the other in terms of strength based on its bond strength. So let's assume that the denomination for bond strength is given by tau. So if you have, by definition, the bond strength tau is the total pull-out capacity which the anchor can give divided by area of bondage. So here this is a simple formula to calculate a pull-out capacity of any anchor embedded using a chemical. So the formula goes like this. It is tau, which is the bond strength, multiplied by area of the bond. The area of the bond, to make it simple, is pi into diameter into effective embedment depth, which in chemical anchor, it is the drill hole depth itself. So where do you get this value called bond strength? How can you find it? So don't worry. Any ETA approved product, any tested and certified product by European Technical Authority would have a published document called ETA, European Technical Assessment, wherein the bond strength of the product would be published for different criteria. For example, you have a range of temperature, you have a range of drilling options, you have cracked and you have non-cracked, and so on. So let's take an example. Let's assume that we live in a very hot country, so our temperature is from 50 degree long term to 72 degrees short term. So I have, for example, an M8 rod. So my bond strength is 7 Newton per mm square if I'm following diamond drilling. If I do a normal standard drilling, my bond strength is 7.5. So using this formula here, where we know the drill hole diameter, sorry, the anchor diameter and the embedment depth of the connection, we can easily calculate the pull out capacity of the anchor. So let's take an example. So here for a 12 mm anchor with a drill hole depth of 180 millimeters, the bond strength would be here. So you can see here it is 9. So 9 into this, putting this in this formula, we get around 61,000 Newton, which is 61 kilonewton. That was the first fact. What are the different type of chemical anchor systems available in the market? So normally we have heard that people comparing different types of chemical anchor, which is not an apple to apple comparison. When we talk about chemical anchors, there are a wide variety of chemical compositions, formulations, and thereby different array of properties. So the most common categories available in chemical anchors, first classified based on the packing, would be, the first category would be foil cartridge or sausage type systems, where the chemical would come in a very soft foil type packaging, like normally you find this kind of packaging for sealants. So this is the most cost efficient way to package a product. So this is the first type. The second type is a solid cartridge, where you can physically feel it's a hard cartridge. Even if it drops down, no problem, it is extremely durable. And then there's another kind of packaging which is mainly used for bulk applications, which is called bucket system or can system. And then there is also another type of packaging called glass capsules, which comes in glass form or as foil system. So that's the way it is packaged and it is available in the market. Now, here is a quick comparison about what are the pros and cons of each one of these. I don't want to go much in detail, but let's say a foil cartridge would be fragile. So you must be careful in handling a foil cartridge, because if it falls down, it might puncture itself. There could be leakages and so on. Another problem of foil cartridges is that they are not reusable, which means once you open a, a foil cartridge, you need to empty it all at once. Let's say you finish half of the cartridge today, you cannot save it for tomorrow. Then you have average shelf life for foil cartridges. It will be in the range of 12 months to 18 months. The best system is to have a solid cartridge, because it is rough, it is robust, it can be reused. For example, you emptied only quarter of a cartridge today, you can reuse the remaining any time during the shelf life. And as you can see here, normally for Fischer range, the shelf life is extremely higher compared to our competition, which is around 36 months, 3 years of shelf life. And then advantage is we have a scale directly on the cartridge, which I would also show you in coming slides. Can system is also durable, it is reusable, but you have a problem in shelf life, and unfortunately no scale is possible or it is available. Foil capsules, like when we come to capsules, foil capsules again are fragile, glass also so, and also, as you might have guessed, the capsule system is not reusable. The foil system, however, has a major drawback. You cannot have a longer shelf life, which means you have to use these chemicals anywhere from 10 to 12 months of the production date, which is a drawback. Whereas glass capsule, you can go more shelf life, which means you get around 36 months from the date of production. Yes. So now, what are the basic chemical components which is being used in the production of chemical anchoring system? So we have different formulations like Vinylester hybrid, Vinylester and Silan. We have Polyester hybrid and Epoxy, which is the most popular out of all this. So the Polyester hybrid system, for example, is the most economical solution. It is mostly used in masonry because of its moderate performance. It can be used only for non-crack concrete applications. It cannot be used in concrete if it is for long term, if it is purely polyester, because it has an effect called saponification, which is like production of soap like a chemical during exposure to concrete for a long time. This is mainly used for non-structural application, lightweight applications like GRC fixings, temporary applications, and so on. The major advantage of a polyester system is its fast curing property. You can load it in 25 to 30 minutes in Middle East climate. The second category is a Vinylester hybrid. It is a Vinylester based motor, but it has got certain hybrid properties. It is an economical solution. It can be used for masonry applications. It can be used for cracked or non-cracked based on the approval document of the product. Some chemicals are also approved for seismic performance, like example Fischer FISV systems. Can be used for post-install rebar applications also if the product is qualified by a third-party approval, like the FISB systems. All these Vinylester-based hybrid systems are also fast curing motors. Now comes Vinylester and Silan. So this is one of the highest performing Vinylester based product or highest performing fast curing system available in the market. It is generally not used in masonry because of the price point. Because of its extremely super performance, it is slightly on the expensive side, but It is often seen as a problem solver when you want to finish your applications fast with a quick fix of the high load conditions. Then you turn on to these systems. It is also, some of the systems are also approved for seismic performance categories. It can be used very well with post-install rebar connections. Also, you have to check the approvals. And there are some capsules also produced which are suitable, which are using this principle. And these capsule systems, as you see on the bottom right corner, are also suitable for use in diamond drill holes. So if you have extremely heavy applications, let's say you have to fix an M30 rod, and you want to finish it quick, drilling should be fast using a diamond drill machine. No problem. The capsule works wonders. It is a very fast curing system like the Vinylesters. You can load in 30 minutes if it is an injection system. If it is capsule, it almost behaves like a mechanical anchor. Trust me, you can load in less than 5 minutes. Now, here is my favorite, the epoxy system, which is also very popular in this part of the world. This is the highest performing chemicals you will find in the market. It is not as economical as a polyester based system, and thereby not used generally in fixing of masonry elements where you require much lesser load capacities. It can be used in cracked as well as non-cracked concrete. Also has got seismic performance categories. It can also be used for post-install rebar connections in Middle East. Mostly epoxy is being used for post-install rebar connection due to one reason. It is a slow curing chemical. So in Middle East, we know we have a hard summer. So in peak summer, it is always best to use an epoxy mortar. I will come into details of why in the coming slides, where you have a factor which is related to temperature and the curing time of the product. I would love to ask one question to all of you now. What is the difference between curing time and gelling time? Any of you who have fielded a chemical anchor installation, you have seen, you have tested, you have supervised, if you have any experience working in chemical anchors, what in your understanding is the difference between curing and gelling time? I repeat, do you understand what is the difference between curing and gelling time? Because any chemical anchor, you will have gelling time and curing time. Okay, I'm getting some brilliant participation. Thank you, Ms. Jinsey. Gelling time no longer workable. Gelling can be adjusted, but after curing, it can be loaded. Okay, yes, Mr. Andre, correct. Gelling time and curing time, you absolutely said it. Gelling time, also called as open time, is the time where after you open the nozzle and you start injecting, it is the initial time where you can take to insert your rod to adjust the rod. So it is also called as working time, because that is the time you have to work on the rod and to install. So during the gelling time, the chemical reaction had not started. The reaction between the resin and the hardener had not taken place. So you still have the flexibility of adjusting your rod. If you have not installed enough chemical, injected enough chemical, you have time to take it out, inject more chemical, fill the hole again, work on it. If it is not 100% plumb, you can adjust it. So this is gelling time. So this is the time within which you can adjust your steel elements. It starts immediately once the mortar and hardener is mixed. So the gelling time is the time which starts the moment when the mortar comes out of the nozzle. Now here is what it is by curing time. curing time is also called as full curing time, minimum curing time, and 1,000 other names based on the market and the country. So this is the time after which the chemical reaction or the curing action is completely done, and you can load this. You can apply the actual load it is designed for. So this is the time after which you can even do a pull out test. Now let's take an example. Let's say I have a chemical motor with a curing time of, let's say, 30 minutes. How much capacity do you think the chemical system would give you after 15 minutes? I repeat, if your chemical system has got a published curing time of 30 minutes, Fischer recommends 30 minutes. After 15 minutes of curing, how much do you think is the capacity it would have attained? Thank you, Mr. Mohammed. Maybe 80%. Okay, right. Anyone else have a different opinion? Okay, I assume no. So let's see. The capacity is 0 kilonewton. The chemical anchor capacity can be calculated or can be guaranteed only after 100% curing time. We have had instances of sites where the chemical anchor were loaded within the curing time, and several reduction in capacities were reported, or failures were reported. So please do not load the anchor within curing time. Wait for the complete curing time, or you will have no capacity. So here is a comparison of gelling time between two of our most popular products, Fis EM Plus, which is an epoxy system, versus Fis V, which is a Vinylester based system. So I don't want to go too much in technical through the graph, but let's get into what is relevant for us. In Middle East, I believe our normal temperature would be 30 to 40 degrees throughout the year. So our slow curing epoxy based systems would have a gelling time of 7 minutes, and a Vinylester system would have a gelling time of 2 minutes. So you can see for epoxy, since it's a slow curing, you have slightly more time to for gelling to adjust, and for the fast curing system you have to be really coordinated, and you have to be little more quicker. Same two different products. Here is the comparison for curing time. For epoxy based system, you can apply the load after 5 hours, whereas for Vinylester you can apply the load within 30 minutes. So you have pros and cons in both. So based on your application, your stage of the project, how fast do you need to finish, do you have enough time, and so on, the decision could be made. And next important fact is knowledge about accessories. If you open the Fischer catalog for chemical section, you see hundreds of accessories, and many it's sad that most of our customers do not understand why there are so much accessories in our range. It is not just to sell more products, it is for installing the product in the right way as it is prescribed as per the manufacturer, which is Fischer, as well as the third party approval documents. So for drilling of rebar, we have certain accessories called the drill guide. This is to make sure that you are maintaining sufficient cover while drilling near to the edge of concrete and near to the existing rebar. We have certain accessories for cleaning. I will also discuss in detail about the effect of or importance of cleaning in the coming slides. It is very important to use the correct accessories to clean the holes, because cleaning might it is accountable for more than 50% of the capacity. You have different accessories for injection of chemicals like injection nozzles, standard nozzles, extension tubes, uh, series of dispensers like manual dispensers, pneumatic dispensers, battery operated dispensers, and lots more. You also have certain accessories for helping with overhead installation, like this wedge over here is ideal for overhead installation. As you can see, you install the product overhead, the chemical tends to leak out and the rod will slip down. So the rod could be secured and the chemical should stay in place using these installation wedges. Also, we have these injection adapters for seamless installation in overhead applications. So let's discuss also a bit about drill hole conditions. So there are certain extreme conditions we face in the application of chemical. Number one is diamond core holes. So diamond core holes are when you prefer to do a coring due to multiple reasons, uh, such as you are hitting a lot of rebars, or the hole is way more deeper and which cannot be achieved using a hammer drill machine. It could be cumbersome, so you prefer to use diamond drill machine. Whatever be the reason, diamond drilled hole is a challenge for any chemical system because the whole surface is much more smoother, which might reduce the capacity or reduce the bond strength. Another factor is high strength concrete. It is very difficult to drill on high strength concrete, so people prefer to use diamond drill hole. Also, big diameters, it's advisable to do diamond drilling because it is a very tiring process to use normal 2.5 kg hammer drill machine to drill some holes like 35 mm or above. Heavily reinforced concrete, it is also very hard to drill using a diamond drill machine when you have heavy reinforcements in your concrete where you want to drill. Thereby, we use diamond drill machines. So, when you use diamond drill machine, there are few things which you have to take care. Diamond drill machine cuts through concrete as well as existing rebars inside. So it is very important that the consultant knows that you are cutting certain rebars and this does not affect the structural integrity of the building. Very important. And what is the difference between hammer drilled and a diamond drill hole? Do you think there should be any special precautions or installation steps for diamond cored holes? Do you think there will be an influence on the load capacity of the anchors? And of course, there is a solution behind every problem. Our solution to this problem is the Fischer FIS EM Plus, world's best epoxy motor with the highest properties and also suitable for diamond drilling. You have to make sure that the product which you're using in a diamond drill hole is approved for diamond drill holes. It can be designed for diamond drill holes, and you have to use a proper procedure for installation. In case of the Fischer systems, you don't have to use additional roughening tools to make the surface roughen because our systems are highly superior. They are adaptable with diamond drill holes, and thereby no additional roughening is required for our injection systems. So in case of Fischer, you have very simple installation steps to be followed, like you clean the diamond drill hole with water, brushing, blowing, injecting, and that's it. Now I would like to show a small video. My marketing department would help me play the video, which shows the very importance of drill hole cleaning. And this is the most important fact which any engineer at site must be able to take care of. Marsuk, can you help me play the video, please? I hope the video was very clear. So I think it's you don't have to speak about the effect of drill hole cleaning any further. It was very well illustrated in the video that if you don't clean the hole, you see there is a drop of less than 25% of the capacity, and thereby it is the most important uh, fact you must be aware of and must be taken care at site level. This is an example of a chemical anchor which was being tested during a pull-out test, and the chemical came out, and you can see it is like dough and flour. The chemical is bonding with the dust, and it is not forming a real bond with the concrete, which is it is supposed to. So it's very important, and it could be catastrophic if you don't take proper care in cleaning the drill holes. Now let's talk about certain concrete conditions. For example, in this video, it shows a building structure with a moving live load. You can see there are certain black lines developed as the ball is passing. So these are the tensile zones in the building, depends on where the live load is acting. So in concrete, these tensile zones are also called as crack concrete. So it is very important to know if your chemical system are approved for use in crack concrete. This is as per the European Technical Authority guidelines, wherein if you are not sure if your area of installation, the location of installation is proven to be under compressive zone or non-crack concrete, then you are liable to consider crack concrete in your selection of anchors and designs. So here is a normal test procedure for chemical anchors under certain criterias. For example, as you can see here, the typical the functioning of the chemical, and you can see the crack width and how many number of tests should be done based on the diameter of the anchor and also certain other references. So typically, so for a chemical which is supposed to be approved for crack concrete, it is supposed to be tested in anywhere from 0.3 to 0.5 wide cracks, and then it is qualified for working in crack concrete and designed for working in crack concrete. So here is a graph which shows the displacement of the anchor in terms with the crack movements and the crack width. So you can see at 0.4 wide crack, you have a 4 displacement. With a 0.3 crack, you have a 2.5 displacement, and so on. So here is further references between displacement and graph and crack width, sorry. So again, if you have more than around 0.5 or around 0.45, you can see there is around 4.2 displacements, and around 0.35 you have around 2.5 displacements. Next category, which is very critical, is the seismic performance category. Are you installing these anchors in a seismic prone area? Does your specification calls for anchors to be qualified with seismic performance categories? And in seismic performance categories, there are two categories called C1 and C2. C1 is the least critical and C2 is the more critical case. So the main difference, as you can see, is the in the qualification is the crack width. For C1 categories, the crack width where it is tested is 0.5 whereas in C2 categories, the crack width which is tested is 0.8 So you have a more wider crack, thereby makes the product more weaker. So not all products qualify for C2. Some products qualify only for C1 category, and some qualify for C2 based on its performance. Here is a condition, an example of premium epoxy FIS EM plus M20 threaded rod. So the blue one shows the blue performance is when you have uh, a static condition, which is not seismic, just static loads. You have a bond strength of around 8.5, whereas in seismic category C2, it drops down to 5. So you can see almost around 40% reduction, 45% reduction. And what about loads and design of chemical anchors? At this time, I would like to stop and ask, do you have any questions till now? Okay, good. I hope it is clear since I don't have any feedback. Let's discuss about loads and designs. So the most important loads or the only loads which you consider for anchors in design are tensile loads and shear loads. So in tension, while you design an anchor, you consider failures such as concrete cone failure, which is checking if the concrete can carry this load, it can arrest the load. Also, splitting failure normally happening in thin members or when you drill too deep inside a concrete member. Steel failure, it is purely depends on the grade of steel which you use. And also pull out failure, which is based on the anchor mechanism. For example, bond strength, it is accountable for the pull out failure. Similar failure modes appear in shear as well, such as steel failure, concrete pry out failure, and concrete edge failure. So all these failure modes must be checked before we say this application for an anchor is safe or unsafe. So any design which is done using the Fischer design software Fixperience evaluates all these failure modes and then tell you if the application is safe and this product is safe to use. Now, here is a very important point. Sometimes we get requests from site engineers to come to the site to perform a pull-out test, but nobody has a clear understanding which load should be tested for. Is it the design actions? Is it the resulting anchor forces? What should we test for? So, and sometimes a misconcept exists that if you have more embedment depth, the solution is much more better. And also diameter, if you have bigger diameters, it is always better, which is not often the case, because we have I'll show you some examples. This is how a typical anchor arrangement looks like, with some tension forces, some shear forces, some moments. And this is design action, what you see on top. This is your input. This could come from your structural model like STARD or SAP. You have reactions at your support nodes. You input in the Fischer software, and this is exactly what you enter. Now, you have 4 anchors, anchor numbers 1 till 4. Here you have resulting anchor forces, where it shows what is the effect on individual anchor. So from this example, you can observe that the highest loaded anchor is anchor number 1, where you have a tensile action of 9.7 kilonewton, which is much higher compared to rest of the anchors in the group. So always you have to consider this factor for while you go for any pull-out test at site. You have to check what are the resulting anchor forces and what are the design actions. So in our recommendation, always you have to test the anchors for the maximum resulting anchor forces. Coming back to the second point which we discussed, here is an example of a case designed using M24 bolts, and we got a feedback from the software that the case is not safe. It is overutilized. Now, instead of M24, let us change it to M16. We get a message that this is a perfect solution. It is working. There is no problem. You can go ahead. So not all cases, if you increase the diameter and the depth, for example, here you have a depth of 125, here you have 84, here you have 24, Here you have 16. So diameter and depth is lesser in this case, and yet you have a much safer result. So don't blindly go with the fact that you just drill more deeper, use a bigger diameter of rods. No, it has to be evaluated case by case, modeled in the software, and then calculated to prove that your assumption was correct. Also, a very important topic, temperature. So temperature is a major influencing factor, especially in the Middle East. So we know our summers are extremely hot and humid. So have you ever faced any challenges with chemical anchors due to heat? So there are certain problems which you might face while you have higher temperatures. Chemical anchors are sensitive to temperature. Also, they are directly proportional to temperature and curing time. So, meaning you have a higher temperature, you have a faster curing time. So, sometimes your temperature is so high that you have extremely fast curing motors, which you can practically do not uh, install. Second thing is chemicals are always very sensitive to temperature, and that is the reason you will see a lot of chemical storage warehouses in this region, because they must be stored in controlled temperature, probably in the range of 25 to 30 degrees. And also, do you think there is any long-term effects due to higher temperature? So let's see. Here is a comparison between again Fission plus M12 in uncracked concrete. You can see in 35-degree long-term temperature you get 18 Newton per mm square, and in 50-degree long-term temperature you get 16.5. So you see there is a drop. That was for non-cracked, so around 5% reduction. In cracked concrete, in our system, it is almost same. There is no difference in reduction in capacity. 9 in 35 and 9 in 50. This is extremely rare to find scenario. Most of the chemical anchors, like one of the our competition here, you see at 24 degrees you have 8 Newton per mm square, but the moment you change the temperature to 43, your capacity drop down to 6. So always be wise in choosing your product, and is it suitable really for your application uh, technically. Also, another important factor is fire resistance. This is also a topic which is becoming more popular. Consultants are more demanding for products which are safe to use or fire resistance. So you have different classification of fire resistance like R30, R120, R240, and so on. Our system, for example, the Fission Plus is tested for up to R240, and also to technically, if you want the anchor to perform under fire or to resist fire, all the other structural components like your through bolt connections, your through and through member connections, everything, is it protected, or you just have a comment from the consultant to just use fire rated anchors. So this is also very important. And fire is rather more damaging to the anchors than seismic or any other parameters, because fire immediately reduces the steel capacity. So you see there is a huge dip in steel capacity while you use anchors. Even if it is M30, you see the drop in capacity is huge. So it's very important to take care of this if you want to design under an exposure to fire. Also, we have another drawback, which is humidity. So we live in a really hot country and also humid atmosphere. So make sure that the chemical is approved for dry and wet drill hole condition. Also suitable for flooded holes if you have standing water in your holes. Also underwater applications. So dry and wet, you have to take care of curing time in dry concrete. In flooded holes or underwater applications, you have to directly double the curing time. It is not mentioned anywhere in the approval, but it is understood that if you have water standing while you inject, then your curing time, say for FICM plus, it's 5 hours. You have to expect at least 10 hours for the chemical to cure because you're installing underwater. This is a case study we would like to show for underwater application. It is an application for fixing of ladders in Dubai Harbor. It is done by one of our most favorite contractors. And this is extremely special application because this stair or this ladder is going underwater into the harbor. So the injection of the underwater fixing points needs to be done also underwater because there is water. So diver need to dive deep inside and inject these anchors inside. So you can see the diver is preparing. He is taking the injection system, which is already connected to nozzle ready, and then he dives deep inside and injects the solution. So we also did multiple pull-out tests to verify our performance, and to say the least, we achieved multiple times the recommended values uh, during above water as well as in underwater pull-out test. For example, this is a test underwater, and we reached at least more than double the load of what we calculated for. So extreme condition also can arise like dry and wet conditions and water fill holes. So ETA approval covers dry and wet condition as well as flooded conditions. Application outside of ETA are underwater applications. So for these applications, you have to immediately double the curing time. We also have certain criteria for certain application. For example, you have a water tank, which is a tank for storing drinking water, and you need to fix, for example, a ladder. Then this installation or this chemical system should be suitable and compatible. It should not contaminate the drinking water. So we have test reports like the NSF, which is valid, and it states that the product does not contaminate water. So very important thing, it also does not harm sea creatures or marine life, which is also a very important aspect in such exotic applications. Shelf life and storage also very important. So chemicals should always be stored in a controlled climate, in a preferably air conditioned area. So you can see there is always a specified storage temperature mentioned for every chemical anchor. So within our shelf life, for example, for FIS-EM Plus, we say it has got a shelf life of 36 months from the date of production. So it also gives a tolerance. Like, for example, there is a power failure in your AC yard, then up to 2 weeks, it is okay in total. So within 36 months time, within 3 years time, you can have a failure in cooling chain of up to 2 weeks in total, which is acceptable, but not more than that. So here is a table which shows shelf life of our products. So FIS-EM Plus has got 36 months, FIS-EB 36 months, FIS-V 18 months, and so on. As you can see, we have extremely good curing time, and expired chemicals after 36 months, they do not have any warranty, they don't have any performance liability, and unfortunately we will not be able to support you if you use a product which is already expired. So please take care of the product which you receive at site. It has got enough time to finish your job, and it does not get expired before that. And the last most important fact is, please try to use only FIS-EM Plus. The reason why I say so is it has got a solid hard cartridge, so it is extremely tough for all the applications and the abuse it can take at site while handling. It has got scale units on the tube itself, so there is reduced wastage. One scale unit accounts to 2 ml, so your people at site can easily understand how much to install to reduce wastage. and always it is reusable within the expiry date. Within 36 months you can close the cap and reuse it next time, no problem. And then it has got comparatively higher storage conditions, such as it can be stored up to 30 degrees. Most of the chemicals must be stored within 25 degrees. So here is a quick guidance on what does it mean by FIS EM plus. FIS stands for Fischer injection system. EM plus is the product name, Epoxy Motor Plus, and 390 is the cartridge volume. This cartridge contains 390 ml, and S is for shuttle, because you have two components, resin and hardener, side by side, so that is known as S for shuttle. Physium Plus has got multiple approvals for crack concrete, non-crack concrete, used with rebars. It can be used in seismic conditions. It can be used very close to the edge. It can be used in C1 and C2 conditions, fire rated up to 240 minutes, highest loads, compatible in diamond drilling holes, smallest edge distance, also tested for drinking water, and so on. And this is one of the only product available in the market with a service life of 120 minutes, which has been evaluated by a third party organization. So having said that, I hope I was able to give some value addition for you today. I hope the content what we discussed today is useful for your work, and I am extremely sorry for overshooting 8 minutes more than the committed time, but I hope it was useful and it was worth the time. So please, now we can have a 5 minute question session. So if you have already posted some questions, I can discuss that. Let's go to the questions. The first question from Andre: can you be so kind to send me presentation that used for webinar? Oh, okay. Sure, Andre, we will arrange to send the webinar copy to you. What will happen when you do pre-stressing the anchor bolt every year? Okay, for what do you? I think this is for mechanical anchors, not for chemical anchors. There is a torque, so this torque should be maintained during the lifetime of the anchor. So, if for some reason the torque might get reduced, there is a procedure that you do quality inspections, and you can maintain the torque. You will not apply more torque than the anchor is applied, and thereby more pre-stressing is applied. For example, an anchor is designed for 50 newton meter. You will only apply maximum of 50 newton meter, not more. So the stress which is induced in the anchor, always the highest stress is always the same. How we can identify the concrete is safe for drilling? Is there any specific tool to identify the suitable location of drilling? Uh, Mr. Siahul Haq, a very good question. The concrete is we say that this is suitable for this particular anchor based on the grade or compressive strength of the concrete which is being used. So normally for anchoring, the recommended or the minimum compressive strength is C20 or 25. Uh, Having said that, we also have certain products which can be used even in C12, but as a rule of thumb, the minimum grade should be C20. So if you can verify the concrete grade is, if it is more than C20 grade, then you should not have any problem installing the chemical anchors. I hope I was able to answer your question. Yes, Mr. Anuj have a question regarding the certificates. Mr. Anuj, yes, we do give a participation certificates for all of the attendees. It is depend on the time you spend in the seminar. If you have, for example, more than 75 to 80% participation during the complete duration, which we get a report from the software, so we issue participation certificates to those attendees. So if you have been attending full time, then for sure you will have participation certificates. Mr. Mahroof has a very fascinating question. Is it required torquing of the anchor bolts? Anchor bolts depends. There are different category of anchor bolts. For example, the torque control anchor bolts, definitely it's a yes. Because if you don't know what is the torque you're applying, then the load is also in a gray area. Maybe you get less, maybe you get more, maybe you get less if you torque more, and so on. So if it is a torque controlled anchor, you should definitely torque it. Even if it is not a torque controlled anchor, like a chemical anchor, you have a maximum allowed torque. So for chemical anchor, there is no setting torque. It will work without any torque, but you should never over torque these chemical anchors, because then it loses the bond. Dheeraj Prajapati has a question. Is there any chemicals which can be used for pre-test PT stands if in case modification required in PT suspended slab? Yes, our chemicals are also suitable for used in post-tension slabs. Uh, we can discuss in detail after this session. You can reach back to me. I will drop down my email, write down my email in the chat window, so you can contact me and we can discuss in detail. Uh, Jeffrey has a question. How can you decide which to consider for concrete, non-cracked or cracked concrete? Jeffrey, also this is a very fascinating question which we often get asked. So the trick is the cracked and non-cracked, as you were able to see in one of those videos, it depends on the structure itself, and most of the consultant, they agree on the fact that 99% of the concrete at site is cracked concrete. But if you can prove that certain location of a concrete is designed to be only under compression zone, then sure you can also design using non-crack concrete. Is there an additional allowance if the chemical anchor is already expired? Can we still use it? This question is from Miller Pineda. Also very interesting question. I was also, before I joined Fisher, I was also thinking the same lines, but unfortunately it's a strict no. There is no additional allowance, which is to avoid this fact. Most of our competitors has got a shelf life of 12 months, whereas we have got a shelf life of 36 months. The reason why we have extended our shelf life is so that our customer does not have to use an expired chemical. So even so, if you feel that there is some chemical which reached your site and it is expired, please do not use it, because it might have a negative impact on performance, which we don't know how much is it. So there is no direct correlation or a thumb rule for how much reduction and so on. So it is a strict no. If not, the cost benefit has to be passed to the client. Does it mean that the product designers are not compatible to the project design? uh, Mr. Satish, I'm sorry, I have a problem understanding the question. I was not able to understand what exactly do you mean by this question. If not, the cost benefit has to be passed to the client. Does it mean that the product designers are not compatible to the I think you are talking about cracked and non-cracked. So if this is what you mean, yes, the product designers are compatible to the project designers, and this is the reason why we have products produced for cracked and non-cracked concrete to match your site condition. And as per the code and as per our explanations, we clearly say that if you cannot state or prove that the anchor is going to be installed in a compressive zone, then please design only with crack concrete values, and most of our products are approved for both these scenarios. Mr. Shashiko has uh, interesting question. Do you have a competitor analysis done with Fisher Chemicals? Yes, we also have data from competition. We also do a comparison, but we are also using it as an internal reference. We don't want to, talk bad about any of our competitors. So we talk more about our products. But it is very easy to compare. You just have to compare the ETA approval documents of Fisher product to any other competitor. You can easily identify which product is superior. If you require any support, you can contact me and I can tell you. Miss Asma Banu has a question. Is it possible to find volume of adhesive used using Fisher software? Yes, Miss Banu, we definitely have a tool called Motor Fix within the Fisher software, which lets you calculate the volume required for your fixing. Also, if you have a printout report from Fisher, it will also state the volume of chemical required for that case which you just designed. Yes, Mr. Satish. Often it is observed that the contract specification recommends higher diameter anchor with increased embedment depth. Okay, yes. So sometimes what is happening is in the contract specification, maybe during that time, the complete analysis was not done. The product was not chosen, and the loads were not certain. So we have seen several conditions where the designer uh, for such cases would mention the embedment depth required to reach the full steel capacity, which mostly in most of the cases is an over design, so that he is putting himself in the safe place by designing under increased embedment depth and higher anchor diameters. But this is how it is. So we are also having a specification team working close with consultants and specifiers to support them with design of anchors. Miss Semi Pradap, I think we already discussed about this question. Just in case if the stocked chemical anchors are expired, how can it be utilized? Miss Semi, this is exactly what I was talking a few minutes back. Unfortunately, you have to use chemical anchors within the expiration time. After expire, if it is expired, then you should never use that chemical. There is no warranty, there is no performance liability from our side. And this is the reason, as I said, our chemicals are made for increased expiry dates compared to any other brand in the market. So please do not stretch or use the product beyond the uh, expiry date which is published. What product from Fisher can match RE100 from Shashika? Yes, Shashika, yes, we have a range of epoxy motors starting from FIS, EP, EB. Both of them are suitable. If you require a design, then I would suggest FIS EB. But having said that, it is not a direct match of this product which you mentioned. It is higher in bond strength compared to this product. So FIS-EB would be a close bet, you can say. Yes, Ms. Shashiko, this product RE10 is a non-approved product which is normally used when you don't need any design calculations. So we have a product called FIS-EP, P for polyester. So that is epoxy prime. So this is what I would suggest for this application. I hope we were able to cover most of the question. Uh, if I miss something, definitely I will bounce back to you with the reply. Also, I would request all of you to please visit the polls window and give us your valuable feedback. Thank you all for your active participation. I hope the seminar was useful. Please, I hope you all provided your valuable feedback under the polls window. And I hope to see you next month with our new online seminars. So I also wish you all a happy long weekend. So see you again for the next weekend. Thank you.